Hi guys, welcome. Myself Venkatesh Gowda and I am from Sri Venkateshwara College of Engineering from CSC branch. So in this video, we shall study about some applications of linear algebra. So let's start the video. So first is the introduction part. So what is the linear algebra? Linear algebra is a branch of mathematics that deals with the linear equations and the representation in the vector space using matrices. In other words, linear algebra is a study of linear functions and vectors. It is one of the most central topics of mathematics. Most modern geometrical concepts are based on linear algebra. Linear algebra facilitates the modeling of many natural phenomena and hence it is an integral part of engineering and physics. Linear equations, matrices, and vector spaces are the most important components of this subject. Now we shall discuss about the matrices that is used in the linear algebra. So what is a matrix? In mathematics, a matrix is a rectangular array or table of numbers, symbols, or expressions arranged in rows and columns, which is used to represent a mathematical object or a property of such an object. A matrix contains of m and n elements that is written in the form m in rows and n in columns in the square brackets that is called matrix of order m cross n. In matrix A, the elements A11, A12, A13, and so on till A1n are the principal diagonal entries. So we can say that the A11, A12, A13 are the elements of matrix A. So this is an example of a matrix. Now we shall discuss about the types of matrix. The types of matrices include row matrix, column matrix, zero matrix, square matrix, scalar matrix, unit matrix, and a diagonal matrix. Now we shall discuss one by one. So the first, it is a row matrix. So what is a row matrix? In mathematics, a row matrix is a type of a matrix that has a single row. If the matrix is in the order of 1 cross n, then it is a row matrix. The elements are arranged in an order such that they represent a single row in a matrix. So this is an example of a row matrix. Next comes with a column matrix. A column matrix is a type of matrix that has only one column. The order of the column matrix is represented by n cross 1. Thus, the rows will have single elements arranged in a way that they represent a column of elements. So, this is an example of a column matrix. Next is the zero matrix. In mathematics, particularly linear algebra, a zero matrix or null matrix is a matrix all of whose entries are zero. So zero matrix is nothing but the entries, the whatever the entries that are given in a matrix are all zeros. Next is the square matrix. What is a square matrix? A square matrix is a matrix that has an equal number of rows and columns. In mathematics, M cross M matrix is called the square matrix of order n. A square matrix having all the elements below the principal diagonal is called upper triangular matrix. A square matrix having all the elements above the principal diagonal is called lower triangular matrix. So we can see an example of a square matrix in which the rows and columns are equal. Next comes with a scalar matrix. So what is a scalar matrix? A scalar matrix is a type of a diagonal matrix. The diagonal elements of a scalar matrix are equal or same. If the elements of scalar matrix are all equal to 1, then it becomes an identity matrix. So we can see an example of the scalar matrix. Next comes with a unit matrix. A unit matrix and identity matrix are same. Identity matrix is a matrix in which n cross n square matrix where the diagonal consists of ones and the other elements are all zeros. It is also called as a unit matrix or elementary matrix. A unit matrix is represented by in or just by I. So this is an example of unit matrix. At the last, it is a diagonal matrix. In linear algebra, a diagonal matrix is a matrix in which the entries outside the main diagonal are all zero. The term usually refers to the square matrices. Elements of the main diagonal can either be zero or non-zero. So these are the example of the diagonal matrix. So now we shall move to the next part of the video. So now we shall discuss about the Gauss elimination method, which is used to reduce the coefficient of the equation and find the value of the variable. So in this method, we shall consider the system of three equations. They are a11x1 plus a12x2 plus a13x3 is equal to b1, a21x1 plus a22x2 plus a23x3 is equal to b2, A31x1 plus A32x2 plus A33x3 is equal to B3. So in this method, we consider a system of three independent equations in three unknowns, where A is equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. So these are the principal diagonal entries of matrix A. So entries of B are B1, B2, B3, and the variable declared in those system of equations were x1, x2, x3. So using this method, we shall find the values of these three variables. Those are x1, x2, x3, and we shall reduce the coefficient of the matrix 2. The method is used to, the method aims in reducing the coefficient of the matrix. So now we shall consider an augmented matrix, that is A colon B. In A colon B, we declare a matrix A and matrix B. So then in the step 1, we use the element A11 to make the elements A21 and A31 as 0 by elementary row transformation. So by using elementary row transformation, we can see that the A21 and A31 elements are converted into 0. Now we need to form a upper or lower triangular matrix by converting any other element to 0. So in the step 2, we use the element A22 dash to make the elements A32 dash as 0 by elementary row transformation. So we can see that by using the step 2, the A32 dash is also converted into 0 and a 0 triangular matrix is formed. So from this matrix, we consider a system of equation A11x1 plus A12x2 plus A13x3 is equals to B1 and B22x2 plus B23x3 is equal to B2 dash. A33x3 is equal to B3 dash, and we shall find the values of x, y, z. So basically, this method aims to reduce the coefficient of matrix A to an upper triangular matrix by converting any three elements, to form a triangular matrix by converting those elements to 0. So I hope the video was informative to some extent. Thank you.